Hello students, welcome to Spectra Education Academy. In this video, I am going to explain few more cases of connected bodies. Yeah, there is an inclined plane. With the inclined surface making an angle theta with the horizontal. The top of the inclined plane is connected with a pulley. So a body of mass m1 is on the inclined surface. This body is connected by another body. So making use of another pulley. So the another body is on the horizontal surface. Connection will be like this. So this is a body of mass m2. Next, then so this is a fixed pulley. Suppose if m1 is greater than m2. So before that, so since the body of mass m1 is on inclined plane, its weight vertically downwards, it is m1g. Then normal reaction is perpendicular to surface of contact. So this is a normal reaction. And component of its weight against normal reaction is m1g cos theta. So other component making the block to move down. So that is m1g sin theta. So if m1 is moving down, tension in the string opposes its motion, whereas tension favors the motion of m2. So free body diagram for first m1. m1g sin theta favors tension opposes m1a. For m2, tension favors, that is directly equal to m2a. On solving these two, so tension get cancelled. m1g sin theta, a common, so it is going to be m1 plus m2. The equation of acceleration will be m1g sin theta divided by m1 plus m2. So you call this equation 3, say equation 2, say equation 1. If you substitute equation 3 in 2, you will get the equation of tension. So T is equal to m2 of m1g sin theta divided by m1 plus m2. Next, so let us discuss another case. Say a body of mass m1 is on the horizontal surface. Let us say on the table. This is body of mass m1 is on the table, and there is a pulley here. String passes over, and there is another pulley. This is you call it as a movable pulley. So string passes, and other end of the string is connected to rigid support, and there is a body of mass m2 whose weight acts vertically downwards, suspended. Now, so here m1 is playing role like load, and m2 is playing role like effort. So first, what is load? The force by which it opposes, the effort. So what is effort? The force used, the force applied to overcome the load. So therefore, in the pulleys and lever system, if effort moves a distance. So here M2 is applying effort. So therefore, if effort moves a distance x2, you call it as 2x2, 2x. If effort moves a distance 2x, load moves a distance x. Load moves a distance x. Otherwise, if effort moves a distance x, load moves a distance half of it. So therefore, it is x by 2. So therefore, now distance moved by the effort is 2x1. That is equals to load moves the distance x2. Well, this you treat as x1, this is 2x. Now, if you want to find out acceleration of m1 and m2 separately, first you differentiate x1 and x2 with t. So dx1 by dt is equal to dx2 by dt. Okay, so you take this is because effort is moving a distance x2 and this is for load. So this is dx2, this is dx1 by dt. Now, so this is going to be 2 v2 is equal to v1. To get acceleration, again differentiation 2 dv2 by d2 dt is equal to dv1 by dt. So now differentiation of velocity is acceleration. So therefore you'll get 2a2 is equal to a1. So therefore you can write a2 is equal to a1 by 2. So if it is one movable pulley, the second pulley is movable here. So a2 is equal to a1 by 2. Yeah. Next. So now free body diagram. So now tension acts. Tension is the reason for the motion of m1. Now this is T. So this is T. Tension in the string connected to m2. So it is going to be T dash, you call it as. So you can say T dash is equal to 2T. Okay. So free body diagram for m1. Tension is the reason for the motion of m1 with a1, its corresponding acceleration. For m2, T dash, m2g is moving down. So m2g minus T dash is equal to m2a2. Then, so you can incorporate a1 by 2 here. So, but what is T dash here? T dash is 2T. m2g minus 2T is equal to m2 with a1 by 2. So you call this equation 2, you call this equation 1. So let us substitute 1 in 2 to get acceleration a1, 1 in 2. So therefore, m2g minus 2 of m1 a1 is equal to m2 a1 by 2. So take other side, m2g is equal to m2 a1 whole divided by 2 plus 2 m1 a1. So you can take out common a1. Then, so this is m2 plus 4m1. After taking LCM, 4m1 whole divided by 2 is equal to m2g. So now acceleration a1 will be a1 is equal to 2m2g divided by 4m1 plus m2. So this is acceleration a1. So what is a2 means? a2 is equal to a1 by 2. What is a1 is 2m2 g by 4m1 plus m2. This is first quantity whole divided by 2. So you'll get A2 is equal to 4m2g by 4m1 plus m2. So this is the equation of acceleration of the second body of mass m2. This is the equation of acceleration of the first body of mass m1. Suppose if you substitute A2, you'll get T dash. Okay, substitute this equation. Let us say this is the equation 2, 3. This is acceleration A1. We call this is 3. This is 4. If you substitute 4, you'll get T dash 4 in 2. So therefore m2g minus T dash is equal to m2 A2. A2 is 4m2g by 4m1 plus m2. Yeah, so you're looking for T dash. T dash is equal to 4 m2 square g divided by 4m1 plus m2 minus m2g. So this is going to be 4m2 square g minus 4m1 m2g minus m2 square g whole divided by 4m1 plus m2. So this is how to get T dash. So half of it will be, so T dash is equal to 2t. So half of this particular term will be T. Now moving to the another case, motion of the massive string. Motion of the massive string. Say, consider a string. Consider a string of mass capital M, length capital L, connected one end to a body of mass. You take this is small m, connected one end to a body, to a block of mass capital M, and then force applied at the end of the string. At the end of the string. So you can understand diagram like this. So this is the block of mass capital M. So this is going to be the string. So here, this is mass M, force applied here. Now, for free body diagram, for M, force favors, tension opposes. So where is the tension? Tension means at the block. Therefore, tension favors capital M, but tension opposes the string. F minus T is equal to MA. So this is for capital M. Tension is only the reason. This is going to be MA. Then tension get cancelled. So F of so take out common A of M plus capital M. So we can even find out tension also. So A is equal to F by M plus M. So tension is equal to M of F by M plus M. Now moving to another case. In case of only half of the mass of the string is taken. So Once again, this is the block of mass capital M. If you consider the portion of half of the mass, so this also moves only because of tension. So T is equal to M of M by 2 with E. Next. So consider a long string. Consider a long string of mass M, length capital L. At its one end, force capital F is applied. Let us try to get the equation of tension at any part of the length of the string. So first, this is a string of length capital L. This is a string of length capital L. Yeah. So let us say force applied at this end at a distance of small l. Now tension at this point. Tension at this point favors the remaining length L minus L. Favors the remaining length L minus L, but opposes the small l. So say this is a small l, this is the remaining length. L minus L is the remaining length. Now, so force per length is equal to tension. Okay, you can discuss even like this also. For the length L minus L, for the length L minus L, tension only favors for the part length F favors the small l, motion of small l favors F, but it is opposed by tension by small l. So tension only favors the motion of L minus L. So let us try to find out. So for this is for both L minus L as well as L. So let us try to find out equation of tension in terms of capital F. So what we can do is get T this side. F minus T whole divided by T is equal to L by capital L minus small l. So you can do this. F by T minus 1 is equal to L by capital L minus small l. So further, F by T is equal to L. If you take this is right side plus 1, so you'll get after you take LCM all that, L minus L divided by L minus L. This is plus 1, then plus L minus L, minus L minus L get cancelled. So therefore you are looking for tension equation. So F of L minus L whole divided by L. So this is the equation of tension. Thank you very much, students, for watching my video. In my next video, I'll explain answers for few MSET questions in the chapter motion in straight line.